Hello guys, welcome to my account. So welcome back to the nutrition management project presented by Aluat Patients or team. I'm going to continue furthermore to give you more details about this project. So the contents of this presentation, we have to talk about the real life problem that is being addressed, the project data set, factors, the features of the data set I've chosen for this project, and so many more. So the real life problem that is being addressed, like I talked about in the last presentation, are the malnutrition diseases. So these are caused out of a problem known as malnutrition. So this results as not eating enough of the right food values, or being unable, like the body being unable to use the given food values. And we saw the outcomes, which include a number of various malnutritional diseases. Like in the pictures illustrated below, you can see a child suffering from goiter. This skinny boy is suffering from kwashiorkor. So all these come as a result of malnutrition. So as we go further on, so this slide, I'm to explain the data set I chose for this project. So I majorly went to different sites, GitHub, Kaggle, and many others. But this, I got it from Kaggle, and it suits right the project we are dealing with. So it's a nutritional values for common foods and products. In this data set, there are a number of I mean food samples like kosher and so on. There are over 8,000 and beyond. So this really gave me like the suitability for this project, and when you go on, like it has a number of food values. So when you go through that data set, it shows a number of food values and the given percentages for each food value, the probability of presence in each food value, and so on and so forth. So those are majorly why I chose this data set. As we go further on, the factors I considered before choosing this given data set. So availability, is this data set available to everyone? So like I said, I was using some websites that are open sources for codes. I managed to get this one. So meaning that it's very much available for everyone. The performance, it is robust. It's so fast, like it can perform the tasks as soon as possible. I can explain the business support. Business support, like when you look to the issue that we are addressing at the moment, it's about malnutrition. And when you look at the data set, it's having a number of foods with their given food values, meaning that it can help us solve the problem or issue at hand. When you look at the disaster recovery, in case this data set contains errors, these errors can be fixed easily. So the desirable features of this data set that make it suitable for the project, it has the name column, whereby there we have to input the name of the food at hand. Maybe you can set a food sample, so you can be going to eat your matoke, and like you input there. So it has also the serving size. You can input the grams or kgs, so you can be like, I'm going to consume 100 grams. It shows you the calories, the total fats, and so on. So here we are to talk about the Bayesian theorem. Many of you are well familiar with Bayes in probability and statistics. So here majorly the Bayesian theorem describes the probability of an event based on prior knowledge of conditions that might be related to the event. So in bias, we are able to predict the outcome given the given conditions. So it can be applied in evaluating depression tests. So a number of tests can be done predicting water quality conditions. So the Bayesian theory is important in such a way that it describes how to update a belief given some evidence. In case they are to say that family has been having only girls, 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 girls. So somebody is able to be like, so also the next generation in that family are only girls, you get. So someone is able to predict an outcome given some evidence. Naive bias is a machine learning model that is used for large volumes of data. So this model is so recommendable during the natural language processing, and it has like different types. It has the Gaussian naive bias, it has the multinomial naive bias, the Bernoulli naive bias. So given the Gaussian naive bias, somebody can predict basing on like if if a condition if a condition comes repeatedly, somebody can be able to predict based on that repeated condition. Applications, naive bias can be applied in real-time prediction, multi-class classification, and the Gaussian naive bias can work on the real-time prediction. Multinomial naive bias can be applied in the multi-class classification. Here we are given many classes and we are supposed to group them accordingly. So also the Bernoulli majorly deals with binary, like you saw in the mathematics, the probability and statistics. So Bernoulli works on binary and it's either true or false. So it can be used in the text classification. So that's all about naive bias. Bayesian networks simply this is a probabilistic graphical model which represents a set of variables and their conditional dependencies. So it can use a cycle graph. So here on this diagram, I use simply to illustrate, you can see that a dog being out or inside depends on the family's presence. So in case the family is out, obviously the dog will be put on guard, and immediately the dog is put on guard, you're supposed to hear barkings outside. So simply we are seeing that different dependency on how the different outcomes depend on the given conditions. So that's it. It can be like, there is another example, an alarm, like if it hears a burglar, it will have to automatically ring, or even some alarms ring when there are hailstones. So simply those are the Bayesian networks in simple terms. So the difference between the Bayesian theorem and naive bias. In Bayesian theorem, we don't assume conditional independence, but in naive bias, there is an assumption of conditional independence. Bayesian theorem states the relationship between joint and conditional distributions. So in joint, these ones have to happen at the same time. The occurrence of another makes the occurrence of the other possible. But in naive bias, it assumes that an event is conditionally independent given another event. As we go further, we are talking about the differences between naive bias and Bayesian networks. So simply they have only one difference, whereby the naive bias is majorly used to assign class labels to the samples from the available set of labels. Then the Bayesian networks, like I said, it's entirely a graph. So it represents a set of variables and how they depend on each other. So here, just mainly there are references that can help you out to get more clue on what I've been talking about. So in case you've not understood anything, you can click on the comment button so I can help you out in the next presentation. Furthermore, acknowledgements go to my dear subscribers. Thank you for liking and commenting on my account. And shouts out loud to Mr. Galiwango, my lecturer, who has endeavored to make me acquire more skills and more in this machine learning program. Thank you so much. See you next time.